This is partial fractions integration. We're going to take this integral where U substitution doesn't work. This is a polynomial over a polynomial where the polynomial and the denominator factors. And that's how I know that this is partial fractions. Polynomial over polynomial where the denominator factors. So I can write that fraction as x plus 5, x minus 2. And so I know that I can write this as two fractions, one with a denominator x plus 5 and one with a denominator x minus 2. And then we're going to solve for what a and b should be. And then once we do that, we'll be able to integrate. So if I get a common denominator on the left side and combine those fractions with that common denominator, well, that common denominator is going to be x plus 5 times x minus 2. And so I would have to multiply the fraction on the left, top and bottom, by x minus 2, and the fraction on the right, top and bottom, by x plus 5. And then when I combine those denominators, I would end up with this fraction. And so here's the left side and the right side are fractions with the same denominator. That means the numerators must be equal. So 4x plus 41 must be equal to a times x minus 2 plus b times x plus 5. And then if I let x equal 2, then on the left side I get 4 times 2 plus 41, which is 49. And on the right side, when I plug 2 in for all the x's, that gives me a times 0 plus b times 7. So then b must be equal to 7. And if I let x equal negative 5, then plugging negative 5 in on the left side is going to give me 4 times negative 5, which is negative 20, plus 41, which is 21. And then plugging negative 5 in on the left side, negative 5 minus 2, negative 7 times a. And then b times negative 5 plus 5 is going to be b times 0. So then a equals negative 3. And now rewriting these fractions, a over x plus 5 and b over x minus 2, with the values of a and b that I just found, gives me negative 3 over x plus 5 and 7 over x minus 2. And then I can integrate each of these terms separately, and I can also bring out the constants of integration, or the constant multiples. This is U substitution for both integrals. Since it's two different integrals, I'm going to use two different variables for substitution. U is equal to x plus 5, then du is dx. If v is equal to x minus 2, then dv is dx. And so the integral on the left becomes negative 3, the integral of 1 over u du. And the integral on the right becomes 7 times the integral of 1 over v dv. Constant multiple negative 3. The integral of 1 over u is natural log of the absolute value of u, where u is x plus 5. Plus 7 times the natural log of the absolute value of v, where v is x minus 2. Plus our constant of integration. We're going to work one more problem. The middle problem's already worked. You can work it and trace through my work. But working this problem, the last problem, again, I know it's partial fractions because it's a polynomial over a polynomial, where the polynomial on the bottom factors the polynomial on the bottom factors into this. And again, we're going to separate that into two different fractions. And then this time we're only going to worry about the numerators. 5 minus x. And then if we created equivalent fractions with a common denominator, our numerator would be a times x plus 1 and b times 2x minus 1. Then we're going to plug in negative 1 for x. When I plug in negative 1 for x, I get 6 equals negative 3b. So then b is negative 2. And when I plug in 1/2 for x, then I get 4.5 is equal to 1.5 times a, so then a equals 3. And then we're going to plug in these values for a and b that we just found, and we're going to integrate. So the integral of 3 over 2x minus 1 dx plus the integral of negative 2 over x plus 1 dx. And then we can bring out the constant multiples. Again, these are both substitutions, so then u equals 2x minus 1, du equals 2 dx, and v equals x plus 1, dv equals dx. That makes the first integral 3, the integral of 1 over, I'll skip a step here. In order to create the du, we have to multiply inside by 2, divide outside by 2, which is going to give us 3/2, the integral of 1 over u du, minus 2, the integral dv is dx, so this becomes 1 over v dv. And then when we integrate constant multiple 3/2, the integral of 1 over u du is natural log of the absolute value. U is 2x minus 1 minus constant multiple 2. The integral of 1 over v is natural log of the absolute value of v, which is x plus 1 plus c. That is integration using partial fractions.